Take a look around your kitchen, and you'll probably find a few cans sitting on a shelf. They might hold soup, beans, soda, or even pet food. They seem simple enough, but have you ever stopped to wonder how those perfectly shaped metal cans are actually made? And here's something that surprises many people. Most tin cans aren't actually made of solid tin at all. So why do we still call them tin cans, and how are they different from aluminum cans? Today, we're following the incredible journey of both tin and aluminum cans, from giant rolls of metal all the way to the finished containers you see in stores. Along the way, we'll uncover why manufacturers use different materials, how machines can produce thousands of cans every minute, and what makes these everyday containers so remarkably strong. So, let's get started, right here, on History of Simple Things. Metal food cans first appeared in the early 1800s. In 1810, English merchant Peter Durand received a patent for preserving food in metal containers. The earliest cans were made from wrought iron coated with a thin layer of tin to help prevent rust and food contamination. These early cans were handmade, heavy, and so thick that opening one sometimes required a hammer and chisel. As manufacturing improved throughout the 19th and 20th centuries, steel became the primary material because it was cheaper and stronger than pure tin. The tin coating remained, giving rise to the name tin can that we still use today. Aluminum beverage cans arrived much later, becoming widely adopted during the 1960s because aluminum is lightweight, corrosion-resistant, and easy to recycle. One of the biggest misconceptions is that food cans are made entirely of tin. In reality, most food cans are made from low-carbon steel covered with an extremely thin layer of tin. The steel provides the strength needed to withstand stacking, shipping, and sterilization, while the tin coating protects the steel from rusting and reacting with food. Inside many food cans, manufacturers also apply a food-safe protective lining. This extra coating prevents acidic foods such as tomatoes or fruits from coming into direct contact with the metal, helping preserve both flavor and quality. Depending on the food being packaged, different types of internal coatings may be used. Everything begins with enormous coils of tin-plated steel arriving at the factory. These coils are unrolled and fed into high-speed presses that punch out circular blanks. Those flat circles are then shaped into shallow cups before being stretched into taller cylinders through a process called drawing. Some food cans are produced using a method called drawn and wall ironed, or DWI, which creates lightweight cans by thinning the sidewalls while keeping the base thicker for strength. Other food cans, especially larger ones used for vegetables or soups, are made using a three-piece design. In this method, a rectangular sheet is rolled into a cylinder and welded along one side before separate top and bottom ends are attached. Once the body is complete, the edges are carefully formed to allow the lids to be sealed later. Before leaving the factory, every can undergoes inspections for leaks, dents, coating quality, and dimensional accuracy. Aluminum cans follow a somewhat different process because aluminum is softer and more flexible than steel. Massive rolls of aluminum sheet are fed into presses that stamp out perfectly round discs. Each disc is transformed into a shallow cup before passing through several stages of drawing and wall ironing. During wall ironing, the cup is forced through precision rings that stretch the metal upward while making the walls incredibly thin. Surprisingly, the sides of a soda can are often thinner than a human fingernail, yet they're still strong enough to safely hold carbonated drinks under pressure. After trimming the top edge to an exact height, the can is thoroughly washed and dried. A protective food-grade coating is sprayed inside. while the outside receives colorful printed graphics and another clear protective layer to prevent scratches and fading. Interestingly, cans are manufactured without their tops attached. Empty cans are shipped to beverage or food companies because transporting lightweight empty containers is much more efficient than moving finished products from the can factory. At the filling plant, the cans are cleaned one final time before being filled with food or beverages. Aluminum beverage cans receive their easy-open lids separately. These lids are attached using a process called double seaming, where specialized rollers tightly fold the lid and can rim together to create a leak-proof and airtight seal without using glue or solder. Food cans go through a similar sealing process. Many canned foods are then heated inside large pressure vessels called retorts. This sterilization process destroys harmful microorganisms while allowing the food to remain shelf-stable for months or even years without refrigeration. One of the greatest advantages of both steel and aluminum cans is that they can be recycled repeatedly without losing much of their original quality. Magnets easily separate steel cans at recycling facilities, while aluminum is sorted using other methods before being melted into new products. Recycling aluminum is especially energy efficient. Producing new aluminum from recycled material uses only a small fraction of the energy required to make aluminum from raw ore. That's one reason beverage cans are among the most recycled consumer products in many parts of the world. So, the next time you open a can of soup or crack open a cold soda, you'll know there's much more behind that simple container than meets the eye. From giant coils of metal and high-speed forming machines to protective coatings and airtight seals, every can represents decades of engineering improvements. It's an everyday object that quietly combines strength, precision, food safety, and sustainability, all in the palm of your hand. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.